welcome back to the first lesson after Thanksgiving break. I hope you had a good break. Let's get started with writing the vocabulary words. So we have 3 vocabulary words, and I want to remind you that when you are writing these words, please pay attention to what the definitions mean, not just writing it out blindly, okay? So starting off with the word solution. So the solution to an equation is a value for the variable. So variable like x or y that makes the equation true. Okay, so the solution is essentially when you solve the equation. There's also a situation called no solution. If you see no solution, that means there is no value for the variable that makes the equation true. And then there's also a situation called infinite solutions, and that means that any value for the variable makes the equation true. Okay? All right, so let's get on to our word problems. So for the first word problem, it says that we need to write a linear equation to model each problem situation and use the equation to answer the question. So a chief starts the day off with a chief. I think that should say a chef. A chef starts the day off with 30 dozen eggs, so that's 360 eggs. After making meals for 9 customers, he is down to 333 eggs. Assume he continues to use the eggs at the same rate. Write an equation for the number of eggs left. How many eggs will be left after making meals for 29 customers? So the pieces of information I want you to pick out from this is the starting value. So what does he start off with? He starts the day off with 30 dozen eggs, which is 360 eggs. So 360 eggs. And then we also want you to look for the rate of change, okay? ROC stands for rate of change. I'm just not going to write the entire words for rate of change. So if you see ROC, that stands for rate of change. So after making meals for 9 customers, he is down to 333 eggs. So the rate is going to be eggs per customer. So how many eggs per customer? So let's figure it out. So he has 333 eggs left, but he started off with 360. So how many eggs is that? How many eggs did he go down? And then if you subtract that, you would get negative 27. Why is it a negative? Because he's using the eggs. So overall, you are losing eggs because you're using them. You're using them up, so it's a negative number because the number goes down. So 27 eggs that he used, and you're going to divide that by the 9 customers, because how many customers did he serve? 9. So rate of change is a division problem. It's going to be a fraction. You can simplify it, but you're going to divide it first. So negative 27 eggs divided by 9 customers gives us negative 3 eggs per customer. Okay, so that's our rate of change, is negative 3 eggs per customer. Now, if we're going to use y for the number of eggs, and we're going to use x for the number of customers, then our equation can be y is equal to, our equation can be equal to y is equal to negative 3x plus 360. Now, where did I get the negative 3 from? That was our rate of change. Okay, that's our slope. A slope is a rate of change. And where did I get the 360 from? That is our starting number. That's the 360 eggs that we started off with. So we have our y equals mx plus b equation right there. So we've written a linear equation to model this problem situation. Now we need to use this equation to answer the question. The question is, how many eggs will be left after making meals for 29 customers? So 29 customers, that means we're going to have x be 29 because x is the number of customers. So let's plug in 29. Y is equal to negative 3 times 29 plus 360. And if you type this into a calculator, you want the negative 3 multiplied to the 29 first. So you do PEMDAS. And so negative 3 times 29, that gives us negative 87. And then we still have to add the 360. And then we have negative 87 plus 360, and that gives us 273. And so this is the amount of eggs he will have left after serving 29 customers. Okay, so your two answers are, here's our equation. They asked for the equation, so I'm going to put a box around it. And then we also used our equation to figure out the solution. So this is our solution. The vocabulary word solution, that is our solution. All right, so you guys can get a chance to try out number 2. Pause the video if you have to, and we'll come back and do it together. Okay, so by now, hopefully you're unpaused. Let's try out number 2. So we have a baseball pitcher starting the season with 307 career strikeouts. And then 10 games into the season, he has 12 strikeouts. Strikeouts divided by 10 games. Strikeouts are a good thing in baseball, so you collect them. It's like every single time you hit the ball so hard that you strike out. I had to Google this, so I didn't even know. But every time you hit the ball so it goes out, that's a good thing. And so you want more strikeouts. So after 10 games, he earned 12 more strikeouts. So we're going to do positive 12 strikeouts divided by 10 games. When you divide that, it gives you 1.2 strikeouts per game. Okay, so we have our starting and we have our rate of change. Now we put it together in our equation. So if your y is the strikeouts and the x is games, here's what you should have. 1.2x plus 307. So once again, where did the 1.2 come from? That was your rate of change. Where did the 307 come from? That was your starting value. Okay, now we're going to use this to help us solve for how many career strikeouts this guy would have after 162 games. So we're going to plug in 162 as our x value. So y is equal to 1.2 times 162 plus 307. I'm just going to kind of write further over there. So 1.2 times 162, that gives you 194.4. Then we have to add the 307 afterwards. Remember, you multiply before you add because PEMDAS. And then you get 501.4. So if we're talking about numbers of strikeouts, then I would assume that this is about 501 strikeouts. Just rounding it. 501 strikeouts. All right, so that was the first two questions, and we will continue on numbers 3 and 4 in the next video.